My dear students, topic today we have the transaction management and its properties. Its properties means transaction properties. So before learning the thing about the transaction, we have the some theoretical part in small way, and we will see what is mean by the transaction and what is the need of the transaction. Okay, so a database transaction is a logical unit. You have to keep in mind the words properly, and this is theoretical part we will see today. And in the coming days or after tomorrow or the after tomorrow, we will see some exercise on the transaction basis. So a database transaction is a logical unit of the processing in the database management system, which entails one or more database access operation. So you have to keep in mind the few things here. We are talking about the you are accessing the information, and after the accessing the information from the database, and after performing some operation, what would happen with the database, and that is done by the one part or one unit that is known as the transaction. So transaction is what ultimately we have the logical unit in terms of the processing, of course, because our information will be processed by some operations. And what are those operations? So we will see in a nutshell, or in a scratch way, you can say the database transaction represent real world events of any enterprise. Now, how you can say it is very simple. Like if I'm talking about the ATM machine, and from the ATM machine, I can withdraw amount on a specific moment. That is time period. And on the same amount, on the same time of the period, if I'm just deposit the amount, so it is also possible. But two transaction can be done at the same time. It is possible or not, and it is to be done by the database management system. So our multiple operation can be done on the one account. So it is also possible. So we will see some exercise today, and what is the sense of the other things we will see. We will cover the important part in simple way. So ultimately we can say the summarized definition or summarized part of the database transaction, we can understand a transaction can be defined as a group of tasks. Now what is mean by the group of tasks? Because in a transaction there could be the many operation or many sub operations, we can say. Like at the in a single transaction, I'm reading the account, and I'm updating the account, and I'm closing the account. So what are the three operations I'm doing over here? So group of the tasks you can see over here. Just let me write over here for explaining purpose. See, the group of tasks, you can understand what I'm doing. I'm reading the account, okay, and I'm updating some information, and at the last I'm closing. Now, to understand this concept, let us take an example. If I have an account in my bank, so I have opened my account, it means I am reading the account. So ABC is my account, and this account is managed by the 5,000 rupees presently. So now I have opened my account, that is ABC account, and it is having the 5,000 rupees. And when I need to update some amount, how I can update? There could be two different options. Maybe I can withdraw or deposit. Okay, suppose I have deposited some amount to the my account, so I have updated my account balance. So account balance, okay, that is I'm writing over here AB, that is account balance, will be updated by the 5,000 plus 500 rupees, something. Suppose I'm depositing 500 rupees. So 500, this is what, this is another operation which is known as the updation. And after updating, if I do not want to perform other operation more, then I can close. So close is my another task. So here you can see the transition can have the many task or a single task. So we can say transition is more important part of any database management system, and it is a logical unit of the processing, and what a kind of the information we need to process, and that is to be managed by the transaction. So a single task is the minimum processing unit which cannot be divided further. Okay, like reading or opening the account. So this is what, this is only single task, but either group of the task we can have. So of course a transaction can have the multiple task. Now this slide is clear to all? Yes, please tell me, this slide is clear to all? What do you mean by the transaction?
Yes, sir.
Yes, sir.
Okay, so now the all types of the database access operation which are held between the beginning and the end transaction statement are considered as a single logical transaction. This is the thing you need to keep in mind. Logical single logical transaction in database management system we have. So now on the diagram or you can see over the slide uh, on this specific moment we are starting or we are beginning the transaction. So database is in will be in the consistent state during the transaction. Let me clear to all. During the transaction that is known as the execution of the transaction, database may be temporarily in an inconsistent state. Why? Because during this transaction maybe data information may be updated or may lose some information. So and to avoid the such thing, so we can say at the time the database will be in the inconsistent state. So after transaction completion, the database information will be in consistent state, and that will not be changed by the anyone, and that is to be held by or that is to be managed by only the user. So suppose here I'm just want to update some information. I just want to add 5,000 rupees to my account balance. I can do. So during this updating or during this execution transaction, maybe the by the putting the wrong information. Instead of the 5,000 rupees, I'm just inserting only the zero. So at the time the adding the 5,000 rupees to the adding the zero to the 5,000 rupees, is there meaning? No meaning. So at the time data base information will be represented by the inconsistent pattern or inconsistent state. So this is known as a state. And from this point we can say, like a process state diagram from the operating system concept, we can say a transaction can also have its own state, since as we know a transaction itself is a processing part or processing unit, of course. So processing unit means processing unit base, not a hardware term, it is a logical unit we can say. So it is a logical unit of the processing. So of course it also belong to the some state that is known as a reading or writing, or we can say closing or start. So during certain state we need to manage the all the information of the database, and that is to be managed by the database state. So you have to keep in mind the all this important property. During the transition a database will be always inconsistent, and this is a important term you have to keep in mind. So only once the database committed or means is saved, the state is changed from the one consistent state to another state. Now see, when you just insert the ATM card in ATM machine, when you are performing the operation like you want to withdraw some amount, and while withdrawing the some amount, at that moment your database become or information becomes inconsistent. Okay, we don't. The database doesn't know the actual state after withdrawing or deposit. Maybe this is a real case. Maybe the while withdrawing the amount, suddenly power fills up, then powers goes down. Now what happened? You did know your transaction is completed. You lose your 5,000 rupee or what amount you have withdrawn. Then, but you did not get the amount in hard copy or hard form. Then so at that moment you will get a SMS again. So transaction is not complete successfully. So your amount will be rolled back. So this is the reason, because database was an inconsistent state. So when you get the acknowledgement after withdrawing the amount, now you will get SMS. Now your account is debited by the some amount. So now because your database is now in consistent state. So during the transaction your database information will be inconsistent state. So this is the point you need to keep in mind. So I have taken this I have explained this concept by taking the ATM's example. So I'm just remembering the points, and I'm telling to all once again, while doing the transaction your information will be inconsistent because there is no guarantee transaction may succeed or fail. Okay, so this is the point you have to keep in mind, because transaction may fail. Like you just want to withdraw a railway ticket. but suddenly while paying the amount, you don't have sufficient balance in your account, then your transaction will not be completed. Okay, but your information will be managed by the IRCTC website for a while moment, because after the few minutes you can again log in and you can book your ticket, that is to be maintained by the some state. But after 2 days you will see, so that is not to be managed by the IRCTC because your transaction was failed. So this is the reason we can say that during the transaction your information the database will be informed the inconsistent manner. Now is it clear to all? And we will see, of course we will see all these concepts by taking some examples. Okay, so now it is clear to all right now? Yes, please tell me, is it clear to all right now?
Yes, sir.
Yes,
Okay,
sir.
good. So now see, let us take an example for the simple transaction, then you will understand each and every concept properly. Suppose a bank employee transfer 500 rupees from A's account to the B's account. Okay, so we want to transfer 500 rupees from A's account to B's account. Okay, this is my point. This is very simple and a small transaction involves several low level tasks. Now see, what is the activity I have to do? So that is not a task. First, open account A. Now read the old balance of the A. Third one is we need to update the balance, existing balance, that is old balance minus 500 rupees. Then new balance we got. Now we need to, here in the fourth step, we need to update the A's balance by the new balance. Okay. So now finally, suppose A have 1,000 rupees. So here we are reading the account A and old balance will be the 1,000 over here, and new balance will be deducted by the 500 rupees. So new balance will be updated by the 1,000 minus 500. So here information will be updated by the 500, and A's balance finally will be the 500 rupees. And now close the account A. So this is the fifth step. So now you can see these are the 5 different steps. These are belong to the group of the task. And now in the A's account, 1, 2, 3, 4, 5, 6 are belong to the group of the activity or group of the task. This is done. This is the one thing we can say that we are doing the transition one. Okay. So this can be done by, or this can be recognized or identify, we have done the transaction one. Okay, first transaction we can say. Now next transaction is happening here. V account will be opened. Of course we have to follow the step number one. We have to open the account B. If we are not opening the account B, now how you can say which account you have to update? Then you have to open the account or you have to read the account, that is B's account. Now we have to read the balance of the B's account. Now third step, new balance of the B's account will be updated by the 500 rupees, and this 500 rupees will be transferred from the A's account. So we are adding 500 rupees, and now B's account will be updated by the new balance, and now at the last you have to close. And suppose B is belong to the 6,000 rupees. So here the old balance was the 6,000 rupees, and in the new balance of the B's account will be updated by the 6,005 rupees, and that is to be updated by the finally balance B balance. So here we have the 6,500. Again, this is also known as the transaction T2. So how many transaction we have here? Two transaction. One is transaction T1 and another transaction is T2. So T1 and T2, these are the two different transactions by which one account will be debited or one account will be credited. So this is simple meaning. So in this example, you can see we have the group of the task, and now all these group of tasks belong to the one transaction, or simply we can say the single unit of the processing, that is T1 and T2. Now this example is clear to all?
Yes, sir.
Okay, so now we have to read some facts about the database transition. Since we are talking about the transition, then we have to follow the some rules and guidelines just like this one. So we have the some facts term. A transaction is a program unit whose execution may or may not change the content of the database. See, it may change or may not the change. This is a fact you need to keep in mind. So while the transaction, if you want to update some information, so we are updating, but we are not updating, and we just want to read the only balance. Like from the ATM card, I'm not withdrawing or I'm not depositing anything, but I'm checking my balance. Okay, how many rupees I have. So this is what this is again also a transaction. Just read the account balance. So that is also known as a transaction. Okay, so next we have the a transaction concept in database management system is executed as a single unit. Of course, this is the point we need to keep in mind. This single unit. Okay, next we have the third point. If the database operation do not update the database but only retrieve the data, okay, this type of transaction called read only transaction, and this transaction is just equivalent to check the balance. Okay, check the balance, check the balance. So at the time you are not writing or you are not updating anything on your main balance. Now you want to see only how many rupees. I have only 1,000 rupees. Okay, so I can see by the finding the mini statement or just see the check balance option. So it's up to you. And that is time you will just read the information. So that's why transaction known as the read only transaction. A successful transaction can change the database from the consistent state to another. Okay, this is a concept we know about part, because there are the two important state which is maintaining by the database. One is consistent, other one is inconsistent. So a successful transaction can change the database from one consistent state to another. So this is the point, of course, we need to keep in mind. Next, we have the database management system transition must be atomic. This is a very interesting point. A database transition must have the its four different properties, and those are known as the acid property. Okay, acid stand for, I am repeating once again to all: atomic, consistent, isolated, and this one is durable. So when your transition is having the atomicity, we can say consistency, isolation, and durable, then you can say now database transition having the this property. So before doing anything, let us clear to more detail about the acid property. So okay, before jumping on that part, let me see the last part or last fact that is we need to keep in mind while doing any operation on the transition or while learning the more detail about the transition. So if the database were is in inconsistent state before a transition, it would remain in the inconsistent state after the transaction. So this point is saying to us, before completion of the any transaction, that its state will be inconsistent state. Okay, and then after transaction is complete and successfully completed, then it will change into the inconsistent to the consistent state. So last point is just nothing. We just only the replica concept of the step number 1, 2, 3, 4th one. Okay, we showing to a successful transition can change the database from one consistent state to another. So here we have the some factors, some information that should be keep in mind while learning more detail about the database transaction. In this 6th point, you have any doubt, then you can ask me right now, and we will see more detail about the acid property. But before seeing all those part, let me know, is it clear to all these 6 points? Any doubt?
No, sir, no doubt.
Okay, so I'm just moving to the my next slide now. So state of the transition. So state of the transition, we have the few different state now. Those are most important, and this is equivalent to the process state diagram. We were remembering this concept from the operating system as well. Now active state, partially committed, committed state, fail state, and terminated state. So active state is saying to us a transition enters into the active state when the execution process begins. And during this state you have to keep in mind a read or write operation can be performed. So when your transition is in active state, then you can perform the read or write operation. It means in any transition we can perform at least two different operations. Those are the first read operation and next one is a write operation. When talking about the partially committed, so a transition goes into the partially committed state after the end of the transition. So one transition is completed, and we can say we have the partially committed. But what is mean by the partially committed? Just like example, I'm taking, you want to deposit 500 rupees. Okay, and in your account 500 rupees. Okay, minimal amount, there's no issue, but you want to deposit. Then before saving the final transaction, you just request to the person or employee of the bank, sir, instead of the 500 rupees I just want to deposit 1,000 rupees. So what you are doing, you at the time your account is was updated for the temporary, but now you just request your transaction can be updated. Yes, transaction can be updated. I just want to update such transaction by the 500 rupees to 1,000 rupees. So at the time you are modifying the transaction, and that is done by the partially committed. So finally it is was not committed, and partially committed we can update the transaction. So when transaction ended, there no issue, but you can update. But when the it is committed, so it means it will reflect to the your relation, it will reflect to the table, or we can say database. So once the database finally saved, then we can't update or we can't roll back the information. So this is the reason. So while applying the partially committed, you are able to roll back, but once it is committed, then you are not able to, because it is permanently reflect to the database. Now again, after final saving or final committed the information on the database, now you request to the employee, sir, I just want to update such transaction. Then at the time it will not be possible. At the time you have to perform another transaction, so you have to deposit the rest of the amount. This is the point. So this is the point you need to keep in mind. And see, partial to committed part is just only the when the your transaction is active state. Once it is done and its life is ended, and we have terminated the state, now close the state. Now it would not be possible to. You have to perform another operation. And next we have the failed transaction. Of course, failed transaction can be done by the due to any technical issues or due to any logical error. So there's a few things are not in our hand. Suddenly you want to withdraw 500 rupees or 5,000 rupees or 10,000 rupees in an ATM card. Suddenly power goes down and ATMs shut down. Then your amount is stuck into your machines, and you got a message, you have a amount is debited by the 10,000 rupees. Then you will request to the banks, I did not get the amount in the hard manner. Then how I can say? So at the time bank will check the CCTV camera and other formalities. So after the 1 month or maybe 2 months, your amount will be rolled back. So this is the point. So failed transaction can be there is no guarantee ki always transaction will be 100% in successful manner. There are some certain chance on which the transaction may fail. So here we have the state of the transaction that is known as a failed state. Now next one is a terminate state, just like a terminate the process. Since process transaction itself is a process, so definitely it should be terminated. So instead of the transition reach terminated state when certain transition which are leaving the system and cannot be restarted. So we have to leave this state, or we can say we have to close the particular transition. So the transition known as the terminated state. Now for understanding the operating system process state diagram, we have the same diagram. First, for what we will do, first what we'll do, we will begin the transaction, and after beginning the transaction in the active state, you are able to perform the operation read and write. And once the transaction is ended, once transaction is ended, so your transaction will be partially committed. Here you want to abort your transition, that is no, you want to roll back something, so you can abort the such transition. So at a time your transition will be considered into the failed transaction. Or after the active, before the end transition, your transition may fail, so you will move over here, that is a active, maybe from the active state to failed. So that is known as the fifth point. And second point is determining that your transaction is ended, but that is not finally saved or reflected in the database. It is partially committed. It may change or it may fail. But after the committed, that is the third step we have. It's showing that your database is finally updated. So here the actual things will be reflected to the database. So here database will be reflected to the database. So I can write like here, reflected to the database, reflected to the database. And now after the committee statement, it is required to terminate the such step. So this is necessary step, or we can say the process transaction will be terminated. Or if transaction fails, so it will be auto terminated. So definitely if transaction fails, so it auto terminated. So there is no issue. So we can say if it is failed, so it is auto terminated. So this is a simple diagram, and this diagram will help you to understand what is mean by the transition. Okay, from this point to this state of the transition, any doubt so far? It is just like equivalent to the process state diagram as you have seen into the operating system subjects. So now tell me any doubt in this diagram. Yes, student, please tell me any doubt.
No, sir.
Okay, so if I ask this question to the examination, then you are able to write this answer, the answer of the question in simple way. Okay. Now, so this is the uh, theoretical contain which describe the diagram of the state diagram of the transition state. So as we have seen, okay, so previously, so this is theoretical, it is written over here. So once the transaction start execution becomes active, it can issue read or write operation. Once the transaction once the read and write operation complete, the transaction becomes partially committed data state. Of course we have third, next some recovery protocols need to ensure that the system failure, and I will tell you the recovery protocol concept while we will study the recovery management. When the transaction is failed, then it is also possible to recover. Just like example, your transaction is failed due to some technical issue, but you did not receive your amount from the ATM machine, and at that time the such transaction can be recovered by the some method, and those are known as the recovery protocol. So we will see of course this part uh, after the transaction, and then we have concurrency, and then we have the recovery. So we have the some levels. So first we need to understand what is mean by transaction and its properties. So next we have the if the check is filled, if means some information is we are looking for that is to be filled, so transaction goes into the fill state, and that is considered as a fill transaction. Now we have the fifth one, the transaction is aborted while it is in the active state, so it goes to the fill state. So of course the transaction is aborted due to some reason. Okay, suppose you want to withdraw the or you want to book your ticket, but you finally got, you don't have sufficient amount to book your ticket, then what you will do, you will cancel your booking ticket. So before doing the payment, you will cancel your current window. So this is what this is we are avoiding the such transaction. So this is the reason, and that is considered as a failed transaction. And at the last we have the terminated state, refers to the transaction is leaving the system. It means there will be no relations between the current machine or system with the transition, because transition is active right now, is doing transition is being executed on the current machine. But when the transition is terminated, so now there will be no relation, or we can say the transition is not no longer live in the system. So that is the reason. So we can say it terminated or the transaction is now dead. So now here we have the question, what is mean by the asset property? As you seen, database transaction must be atomic, consistent, isolated, and durable. And this is the fact of the database transaction. So same thing we need to learn about the what are the asset properties. So asset property is a very interesting part. So here I'm explaining this concept by this PPT. So here first one we have the atomicity. Atomicity is very simple concept. You can say either all operation of the transaction are reflected properly in the database or none are. So it means if you are doing something, that should be reflected to the value. And suppose in a relation student, in the student relation, I'm just having the student name, but I don't have any value. So what does it mean, null value? So there is no sense to represent the null value. Student name should be something. And if I just want to something updation or anything, that should be reflected to the actual database. So this is done by the Atomicity. Now, consistency is saying to us the information we are taking, that should be correct way. Like is I'm taking so I'm putting your is xyz, that is xyz, it means what, I'm taking the alphabet. So is cannot be xyz, so this is inconsistent data. So consistency, if I'm saying to all, so consistency means the information must be actual, and that should be belong to the actual data type, and the information must be correct way. So execution of the transition is the isolation that is with no other transition executing currently. So preserving the consistency of the database is required when you are performing the multiple transaction. So database information should not be the information should not be violent when you are performing the multiple transaction. So information should not be loose. If you're losing some information while performing the transaction, then what is sense of the applying this consistency property? So consistency means the information should be correct and appropriate manner while performing the transaction. The isolation you can understand. The isolation I will explain by simple way. Suppose you have the two transaction, that is T1 transaction and a T2 transaction. In T1 transaction is also having the own sense, and T2 transaction also having the same sense, in a different sense. The T1 transaction is not dependent on T2 transaction. Now keep in mind this transaction is not depend on the each everyone, but it can be transaction T1 can depend on the transaction T2. There is no doubt. But right now we have seen transaction T1 and transaction T2 are independent from each other. But now you can see when the transaction T1 is executing, transaction T2 will not execute at a time. So when this transaction is executing its set of the task, at a time the transaction T1 will not execute its set of the task. So this is the isolation or integrity between the both of the transaction. When this transaction is T2 transaction is executing its set of the task, then transaction T1 will not execute its any set of the task. So this is the isolation. It is just like a equivalent to say that presently you are taking the class by the online mode by from your home, but suddenly you are saying, sir, I was present in the campus. So how it is possible? Because at a time, on the particular moment, you can't perform two different task. Okay, after 2 days or after the 1 hour, you can say, sir, I was present in the campus. So I can agree, because at a time you were absent. You were absent means you were present into somewhere else. So this is a considered as a two kind of the transaction. So isolation is saying to us, isolation means we are talking about the integrity between the two different transaction. Let me clear to all once again, transaction T1, transaction T2 may depend on the each other, but right now here we have the two transaction T1 and T2, both are independent from each other. So while performing the its set of the operation of each and every transaction are not depend on the each and every one, but the execution is going of the one transaction is will not reflect or will not affect the other transaction. But when the transaction the T1 is executing, transaction T2 will not execute, and transaction T2 will execute. When the transaction T2 will execute, then transaction T1 will stop for a while. So this is a isolation. So once the transaction is completed, then another transaction will be started. Like say, while sleeping on your bed, uh, you can't drive a car. Okay, this is a simple sense. One transaction in there drive a car, other transaction is sleeping on the bed. But while sleeping on the bed, you can't drive a car. So these are two different things you can't perform at the same time, and this can be done by the transition management system. So transition management system is saying to us, two transition cannot be run simultaneously. If it is possible, then we need to have a concept that is known as a concurrency control. And during this concurrency control and concurrency education, we will see day after tomorrow, there is no issue. But right now, let us understand what is mean by the transition. Okay, so this isolation is clear to all. First, let me know. Okay, inconsistent atomicity and isolation. Let me know the isolation is clear to all. Yes, please tell me. Isolation is clear
Yes,
to
sir.
all or not? Okay. Should I explain once more about the isolation?
So you can move on.
Okay, so I'm just moving to the my next property, that is durability. See, durability is saying to us when the transition may fail. Okay, there's maybe so many chances transition may fail. So when a transition is failing due to some technical issue, but whenever we need to recover some information from the failed transition, then the database should has ability to get the data, or is has ability to, or should have the ability to retrieve the information. So that's why I'm saying over here durability is necessary property. So just like atomicity in consistency and isolation and durability, that's why while learning the database system, it is required to understand the asset property. So when any faculty who will teach the database system in the second class, hardly in the second class, each and every faculty will inform or tell about the, you should keep in mind all this property and this is basic property. But I'm explaining this property here because I've already explained, but here I'm explaining deeply manner. Why? Because now this property really belong to the database, and this property is required to learning the transaction processing system. So the system which belong to the transaction system, that is known as TPS, transaction processing system. So in the transaction processing system, we need to manage all the transactions. So that is under come the study which is known as the transaction management. So durability is saying to us after transition is completed successfully. So the changes it has been made, the database persist, and even there are system fail. So we need to keep in mind this point while learning the transition or asset property of the transition. So in this is the summary of the slide I have written over here. Now see, here we have the more theoretical part over here in deeply manner. So there are notes purpose. I'm just leaving or I am just skipping the slide. From this slide, you can read the all the steps properly. So it is written to the technical steps, so you can read out. There is no issue. And here also I have written here the some other other way of the asset property. The sense are the same, so there is no issue. But here this is the simple points which describe the asset property into a specific way. So that's why I just stopped my PPT right now to explain over here. Now this is the concept. So now I'm moving to the my next concept over here, that is the asset property in database with an example. If I'm speaking again what is mean by the asset property, so let me explain this concept by the example. Okay, so now see this example. First we have the transition one begin x equal to x plus 1. Okay, this can be written like this one, x equal to x plus 50. What I'm doing over here, I'm adding some amount into the x balance, and y is y minus 50. What I'm doing, or this is enclosed into the begin and end. Okay, you can understand this diagram or this point like this one. So under the begin and end section, what I'm doing, I'm updating the balance of the x by the 50 rupees, and updating the y balance by the deducting the 50 rupees. So this is first transaction. So transaction one is transferring the 50 rupees from account X to account Y, as we have seen. So on account X will be updated by the 50 rupees. Okay, and from 50 transferring 50 rupees from X account to XY. So uh, this should be Y account to, actually Y is deducting. Okay, this should be Y to X account because X account is credited. Now transaction 2. Transaction 2 is saying to us, this is transaction 1 was. Transaction 2 is saying us account X that is to be updated by 10% increment. Okay, what is the value of the X containing by, that is to be updated by the 10% increment. Okay, interest. And same thing it is also happening with the Y account. So both account X and Y, both are account updating by the or in credited by the 10% interest. So here we have the two transaction. I'm writing here one transaction T1 and transaction T2. Now read this point. If both transactions are submitted together, so there is no guarantee that the transaction 1 will execute before transaction T2 or vice versa. So if you are submitting to the machine, both transactions should be executed perfectly. So transaction T1 and transaction T2 will how you can say which transaction will execute first, because we have not given the sequence. This is my point. I am coming on my point. We in our machine we are putting the two transition T1 and T2, so but you did not specify the sequence, and that is known as the schedule, or we can say serializability. So we have another concept that defines the serializability of the such transaction. It means we are assigning them serial. Transition T1 should execute first, transition T2 should execute second, or we can say that transition T2 should execute first, or transition T1 should execute next. So but here we don't know the sequence of the both transaction. Then at the time, how we can say, how we can say there is a guarantee which transaction will be executed first. Now think, if you are doing the transaction one first, then X amount will be updated by the 50 rupees and deducted by 50 rupees deducted from the account buyer. The resultant balance of the buyer and X will be the different. Now then you are performing the transaction T2. Okay, then you are incrementing 10% from the 10% to the your this X and Y. Now what value will be updated at the times? Now tell me. So update at each and every time the information will be change. Here I mean to say change over here. Then you can say, see, I'm taking a simple example. Suppose I'm executing first transaction T1 and then T2. During transaction T1 and T2, this order X will be updated by or X, suppose X is 100 rupees. So X will be updated by the 150, and Y also having the 100 rupees. So Y value will be the 50 rupee. Okay, and then X, and we are performing the next transaction T2. So X will be updated by the 10%. Now see, so 10% of the 150, that would be the 165. I'm multiplying or adding just like this one, or we are getting. Okay, so right now I'm just getting only. Okay, now see, just let me correct this part. So I'm getting only the 10% part of the X. So I'm updating. So okay, it will be updated. So finally we'll get the 10%. So 10% will be the 150. 150, 165. Okay, now it was correct. Now y would be the 50. So we are creating the 5% of 55 something. Now this is a transition 1. This is a transition 2. If we are choosing the sequence T1 and T2. Now this is clear to all. Let me know. Yes, please tell me. This point is clear to all. If you are choosing the sequence T1 and T2, then what would be the value which is to be updated by the X and Y? If you are assuming X value 100 or Y value 100. Now tell me, is it clear to all?
Yes, sir.
Okay, but if you are choosing the order T2 should execute first and T1 execute the next, then what would be updation? Now let me clear. T1, so here X will be by the 10%. Now what would be the value? So it would be 110. Now value of the Y will be 110, because we are incrementing, or we are credit the 10% credit to the both account. So now after performing the transaction T2, we are executing transaction T1. Now X will be updated by the 50 rupees. So that would be 160. Now y will be 60 rupees. Now see, now see the sequence of the both transaction T1 and T2 and T2 and T1. So see, after choosing the different order, finally we are getting the different output. So asset property in database with example is saying to us there's no we can perform any transaction, there is no issue. We can see the all the properties of the this transaction maintaining by the atomicity, consistency, isolation, and we have the durability. So here we can see first transaction T1 will complete, then transaction T2, and then transaction T2 and transaction T2. But we don't know the concept of the which transaction should execute first. So here I am choosing T1 and T2. So we are getting the value of the x and y like 165 or 655. But I am choosing the order T1, T2 and T2, T2 and T1. So I'm seeing the value of the x value 160, and you can see the y value 60 rupee. So both values are different from the each and every sequence of the transaction. So for doing so, we have a concept that is known as the schedule, and we have the schedule. We have the schedule or the term that is known as the serializability. 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 So transaction in the transaction processing system or transaction management, first we need to understand what is mean by the transaction, then what is the sense of transaction, and what are the various property which is to be held by the transaction. If this concept is clear to all, now then we can move to the next concept. So before jumping or before moving to the next concept, please let me know right now. Please let me know right now. Is there any problem? Just tell me.
No, sir.
Okay, so in the coming classes, you have to keep in mind the thing while looking for the schedule and seriality. So during the class I can ask the answer, I will share my some exercise over here, and so tomorrow, day after tomorrow, please stay connected with the classes, and definitely you will see some numerical part of the numerical portion of the transition processing system, and you will see that how to schedule the transition and what is the sense of the seriality. Okay, so this is the point you need to keep in mind. Now the most interesting point, so this is again I'm just putting the star to keep in mind two operations. As I told you from my lecture, and I'm speaking again, a transaction. Now see here, read and write. So active state is required to have two different operations. Those are read and write. Okay, so same thing we have to over here. Transaction access data using two different operations. Those are read and write. So let us execute or let us understand the concept one by one. Read X. Read is one operation. And what is X? X is means some information or some data item we are passing over here. So read X means which transfer the data from X from the database. Read, let me clear it all. Read means which transfer the data item X from the database. It means what is the sense over here? We are reading, or we can say we are fetching. Okay, I can write in simple way. We are fetching the information, fetching the data from database, from fetching the data from DB. Okay, just like this one, if I have a database over here, okay, just like this one, if I have database, so if the information is coming from database, so what I can perform, I'm just doing the operation read, and this X belong to the data item. That could be anything, just like A is name, date of birth, and so and so. And this reverse part of the read, we can say if you're writing something to the database. Okay, if you're writing something to the database, then we have the write X, right? X. So which transfers data item from the local buffer to the transaction. It means we are writing something to the database. It means writing writing to the DB, to the DB, to the DB, and to the DB from the local buffer, okay, where our information is stored. So if we want to transfer our temporary information to the permanent, then we can say we are transferring our information from local buffer to the permanent storage device, that is our disk. So what we are doing, we are writing the operation. So writing to the database. Yes, these two operations clear to all. Please let me know this. These two different operations is clear to all. Or read operation and write operation.
Yes.
Okay. So now, okay, let me write over here. This is what this is a database. Okay. Now, see, in our exercise will be maintained by the this kind of the pattern. So we will see and we will understand the transition management in database management system like this pattern way. So let the TI be the transition that transfer the rupees 50 from account A to account B, and this transition can be defined as, okay, so now we are following the a real kind of a numerical that will be followed by the Henry of course book. So of course we will take the same concept. Now this is the pattern we need to follow solving the problem. So far we have seen the general way representation, theoretical way, but the numerical way, how you can show, how you can represent your problem, that is done by the like this one. So see, Ti is a transition on the some instance. So Ti is saying to us that a transition I, and this transition what you are doing, we are transferring some amount from A to B, A to B. It means A amount, A balance will, A balance, A account balance will be detected and B balance will be updated. First, what we are doing, reading, but you are not reading from the account balance, then how you can perform the operation? No. So this is a necessary part. So first operation we are performing read. It means we are reading the some information from the database. So we are reading the A. So A is our item that is belong to our account. Now A's information will be detected by the 50 rupees according to this question, of course. Now we are writing the A. We can write the A. So we are writing the A, no problem. We are writing A. It means from when you're writing the A, it means A balance is updated. Here means A's balance is updated. This is a point you need to keep in mind in the coming classes. Then you will see here A balance is updated, but not so far B balance was updated. Okay, A balance is not, B balance is not updated so far, but A balance was updated. So A balance was updated. Here writing means we have updated the balance of the A. Now here I am point. Before reading the B, suddenly power goes off. A balance was updated and B balance was not updated. At this moment, your recovery management play important role to see the transition was succeed or failed. Okay, this is my point. So a transition can be complete when it gets some acknowledgement or when it's follow or it gives a message that is successfully. But suddenly before reading or after writing the A, now it found that suddenly transition failed. So A balance was redirected, but B balance was not updated. So at the time, recovery play important roles. Okay. So we will see that part in the coming classes, but we need to keep in mind the point. Now here A balance was updated over here. Let me draw the arrow. Now read B. Now B balance will be updated, and now here will be updated here. So this is what you can see. This is what here what we have over here. Here we have the some. This is known as the some set of the task. Set of the task. This set of the task will be done by or will be executed by a transaction. A transaction. Okay, one transaction. If one set of the task is not completed, and we will see this transaction is failed. So each and every set of task under a transaction should be executed properly, and or it should be informed the successful manner. Suppose writing the B or updating the B balance, suddenly power fails, so it means transaction is failed. Okay, so doing this point we need to keep in mind. So set of the task which is come into a transition that should be completed, then we can say transition is successful. So a transition can be successful, we can say transition can be successful when all set of the task executed. Okay, executed. But when you can say transition is failed, transition is failed, it means minimum minimum one or minimum one set. Actually we can say minimum, maximum could be all, but minimum one task is failed due to any reason. Okay, so this is the point. So this is just idea about the transition. Yes, please let me know, is it clear to all with this picture? Is it clear to all what is mean by the transition failing or transition
Yes, sir.
successful? Okay, so set of the task means all the set of the task which is also set of the task which is undercome into a transition that should be executed properly, then we can the transition is successful, else it is failed. And since a transition can have the many list of the task, many set of tasks, 1,000. So this is an interesting point where we need to see all those points properly, should be recovered, should be concurrent or not. So this is an important point. Okay, with the coming time to time we will see all these concepts, but the theoretical part or some basic concept is required to know more detail about the transition. So state transition diagram of this transition, we have so active, partially committed, failed, and committed, never. See, this diagram is completely inspired by the operating system. So I have just taken this diagram here for only notes purpose, not nothing especially. But this diagram we have already seen into a different pattern like this one. See, we have seen here. This diagram is the first diagram is same as there will be no issue. But previous one was very easy, and this diagram is taking the reference from the operating system diagram. So that is why I put it over here. Now, this is the question: what is the schedule? Now, this schedule is required when you saying a transaction T1 should execute first, or transaction T2 should execute first. Now, see, let me clear to all. If I'm choosing the sequence T1, T2, and if I'm choosing the order T2, T1, the resultant transactions output. Okay, the resultant, let me write over here, the resultant transaction output, the resultant transaction output may differ. Okay, may or may not. Okay, may or may not depend on the what kind of the task you are performing. So may or may not differ. Since if I'm reading a transaction T1 or I'm reading a transaction T2, okay, transaction T1 T2, I'm just only the I'm only using the read operation, and I'm doing into transaction T2 and transaction T1. So in both transactions order or sequence, I'm just doing the reading, so there is no sense, there is no issue. But for writing, definitely the some information will be updated on the different pattern. So we need to see what kind of the task we are performing. So at the time, schedule is required. A schedule is process creating single group of the multiple parallel transition. Okay, this is the point you need to keep in mind. Multiple parallel transition. So it means in any movement we are executing one transition, but it is also possible on a single movement we can execute multiple transition. Like this one, I'm taking a very simple example. Now you are deposit suppose 1,000 rupee from your ATM card, or on that movement your family member deposits some amount on your account, same account from which you are depositing. So at the time two parallel transaction can be done on the same account, and that is to be managed by the, that is known as the multiple parallel transaction. So we can manage the multiple parallel transaction. So it means transaction T1 T2 we have, suppose. So T1 and T2 run or execute parallelly. And how it is to be executed parallelly? So we need to see this point. So this is a point. Here we need to learn the schedule. So and execute them one by one. But keep in mind this important point, on the both transaction we are looking for. Then we can't execute, we can't execute the right operation simultaneously. We can't we can read, okay, on the same moment we can read, there's no issue, because reading there is no issue. But you are writing the operation on the same thing on the parallelly, then we can't do. Okay, by that taking the some example we will see. It should preserve the order in which the instructions appears, of course. This can be done by a very simple example, so I will tell you more detail about the example through the schedule. And here the thing is known as the scheduler. Before moving to the next slide here, just let me clear to all once again. If the two transactions are conflicting the same operation, like writing, like this one, on the same schedule you have now on the Saturday or Thursday, Friday, suppose you have an exam. On the same exam time you have to attend another meeting. Then what happened at the time, your info your meeting and your class will be conflicting. It means you can't be part of the both thing at the same time. Either you can attend the meeting or you can attend the class only. So this is the point you need to keep in mind. This is the point you can manage. For the few minutes you can be the part of the meeting, or after you can jump to the class as well. After the 10 minutes you can jump to the class, then after attending the class 10 minutes then you can jump back to the your meeting. So parallelly you are looking for the meeting and class. So at the time there is no confliction. Okay, there is no confliction. But we are looking for the meeting simultaneously, or we are attending the meeting simultaneously, we are attending the class simultaneously. So there is a information is conflicting. So this kind of transaction known as the conflicting scheduling. We will see, of course we will see by an example, so no problem. So let me just give you some idea about theoretical part. So if two transactions are executed at the same time, as I told you, the result of the same time, the result of the one transaction may affect the output of the other. Okay, so of course this is the point we need to keep in mind, and I will tell you more detail about the by this schedule concept or scheduling sense of other thing with the about the example. Then you will see, or you will feel really it is happening. Now example like this one. See, initial product quantity I am taking the 10 rupees, no issue. First transaction I am having the update product quantity to 50. Suppose I have the QT by, there's a, I'm reading the QT by. So I'm just what I'm doing, I'm reading. Now see, there is one operation that is initial product quantity is 10. So QTY is 100, so 10. This is the this part. A reading is I'm doing over here, and this is completely showing to us Q2Y is updated by the Q2Y plus 50. Now after seeing this point, now let me know. See, just let me know. If I'm just reading the first transaction, okay, QTY is initialized by the 10 rupees. So there is no issue. I'm reading the first transaction, update product quantity to 50. So first what I'm updating, QTY is updating the 50. So suppose QTY 10. So now QTY is updated by the 60 rupee. Okay. When I read, when I do the next transaction, I read the quantity. So of course now quantity, what value I read, please tell me what value to be read by the transaction T2 over here. If I'm choosing the sequence T1 comma T2, now tell me, first I update the balance of the QTY, and then I'm following the transaction T2. So now what value of the QTY will be? Please tell me what value of the QTY will be?
60.
60. Okay, why 60? Because the quantity value is updated by the 50 before it's reading. So here, after you are reading, after updating you are reading, so definitely 60. But if I'm just follow the order t2 comma t1, then first it will read. First it will read, so qty will be 50. Qty will be read as a 50, and then it will be updated. Then it will be updated. So initially, as I see at the last what value I have read out, okay, so 50, and then it is updated. So both things are different, and the sequence of the schedule of the transaction T1 or T2 is depend on the schedules. So at the time schedules is required. So I need to schedule transaction T1 first or T2 first, and this is done by the schedule or scheduler, we can say. So here it is written over here, if transaction T2 is executed before transaction T1, so outdated information about the product quality will be read, that is 50 only. So hence the schedule is required. First you need to execute the T2 and then execute the T1. So schedule is required over here. So parallel execution database in inevitable. So this is the key point you have to keep in mind. Parallel execution in database is not evitable. Okay, this is the point. So what parallel execution is permeated when there is an equivalence relation, when there is an equivalence relation amongst the simultaneous execution transaction. So parallel execution we can't do, but it also possible, but we need to have the some equivalence relation, and that is done by the equivalence thing. So those are over here. Now see, those are I'm telling over here, but I am not putting over here, but I'm telling to by speaking over here. That is conflicting equivalence or reading equivalence. Okay, you are reading the balance of the both accounts simultaneously, there is no issue. But you are reading the you are updating both accounts simultaneously, then at the time it is not possible. So see, think the point, is it possible or not? A transaction cannot read or write the operation on the same account simultaneously. Either it can read or it can write. So this is the point. More detail about the other things I will tell you by this example, concurrent execution. So concurrent by the concurrent execution you will see what is mean by the parallel execution. So parallel execution is not possible, but it can be done by the some equivalence properties. And what are the equivalence property? And that is counted into the concurrent executions. So when I tell you more detail about the concurrent execution, then before that I will tell you what are the sense of the what is the equivalence property. So there are three types of the equivalence. So that is view equivalence or read equivalence or conflict equivalence. So mostly view equivalence and conflict equivalence is applicable, so mostly. But I will tell you with the help of the example with different kind of equivalence tomorrow. So tomorrow you will have to come to attend the class properly.